So let us build a system which predicts the percentage of a student based on the number of study hours. So what we are going to do is basically we have the data as given here. So this is the given data. So we have hours and scores. Based on that, we have to build a system which predicts the score for a given hour. So we have data like this. So now to build such a system using Python, so we need to get this data in form of file. So what I'll do is I'll convert this into a CSV file. So the procedure to do that is basically very simple. Just paste the data here. Then you save the data as a CSV file. So if we save with some thing like this, so we have the CSV file ready. So we have got our CSV file successfully. Now, let us go to the program, which I have done using the Colab. So I have already imported the data set here, which is the score.csv. So when we are dealing with data, we have a very useful library known as pandas. So what this pandas does is basically it provides us with various functions which allows us to manipulate data in the form of data frames and find median, mean, mode, etc. on series, which is basically an individual column of the data frame. So now let us see what we get after converting the given data set, that is score.csv, into a data frame. So we get this, the same data set in the form of a data frame. So now let us study the relationship between the two variables, which is hours and scores. From our discussion earlier, we know that scores is the dependent variable while hours is the independent variable. So now when we are talking like this, the relationship we can discuss, we can find it through this, that is df.core. What this basically does is find the correlation coefficient between the hours and scores, between the two variables. So if we see here, we have the correlation coefficient as 0.976, which suggests a very strong positive correlation between these two variables. That is, as the number of hours increases, the score will also increase. So this is what is suggested by the correlation coefficient. Now, let us go and prepare a model which predicts the score. So the best type of model for this is the ordinary least square method. So what is this? So as we can see here, so this is the ordinary least square method where the data sets, so the points in the data set are these dots. So what happens is that this is our model. So this is basically a line drawn around these points, drawn along these points, better to say, such that the square of the error term. So what is the error? The error is basically the difference between this and the line here. So basically this amount of the space, I mean, this basically this difference between this and this is basically the error. What error in physical terms we can say is that what's the difference? What's the variability of our model? By how much does our model differ from the actual data set? So this is what is suggested by the error. So the square of each error term and the sum of that is what constitutes this linear regression model. So what happens is that the sum of squares of all these error terms should be minimum. So as it is given here, minimize this given function, which is nothing but the sum of the squares of the error terms. So that is the ordinary least squares method. So why we chose this method is because we have a very, very strong correlationship between this. So we can expect the data points, the points here, to be along a straight line. That's why the ordinary least squares method is best for in this case. So in order to prepare such a model, I use a useful library known as statsmodels.api. So what this does is basically, it has several functions which give us the model. So this is one among them, ordinary least squares. Similarly, we have lots of other models. So Gaussian models, then some ANOVA models, and there are so many other models and multiple regression models, etc., etc. So we have various such models already pre-built in this module. So what we do is that first we create variables which denote the columns. So these are our two columns, R's and scores. So for that, what I do is that X I denote it as the R's column and Y I denote it as the scores column. So this is how I access them, df.rs, df.scores. So that's the use of data frame. So now it is possible to deal with the individual columns of a data set. So then what I do is I do this command so that we can convert it into a required shape. So what happens is the OLS model does not directly operate upon the X, Y, and X variables. Rather, it requires us to transform the X variable into a different shape so that it can be processed more efficiently. So now, after doing this, so it's given add constant because it basically adds a constant to each and every point in the column. So after doing this, we directly call the OLS method on y comma x. So why I put y comma x is because y is the dependent variable, that is the score, and x is the independent variable, that is nothing but the r's. Dot fit. So this will fit an ordinary least square method like this. So it will fit a line like this. And model dot summary. So now if we run this, so we can see here all the statistics related to this model is shown here. For example, number of observations, residuals, the R score, which is a very important statistic. So what this R square basically tells us the performance of the model. And in this case, the 9.953 or 95.3% suggests that it's a very good model. And we have constant as 2.4837, R's as 9.7758. So what are these two terms? Let us see. So from here, this is nothing but the constant term, while the slope of this line is nothing but the other term, which is the 9.7758. So this is our model, which is nothing but a straight line. So in geometry, we represent the straight line like y is equal to mx plus c. Same thing here. Instead of saying mx, we put it as bx, and instead of c, we put it as a. So y is equal to a plus bx. So it's nothing but a straight line. So now this is, so our model is basically this, that is y is equal to 2.4837 plus 9.7758 into x. So now if you want to coding, like if you want to obtain the values through coding rather than seeing it here, we can obtain it like this, that is model.parameters. By doing this, we obtain the parameters. So these are our two parameters. So to make it more specific, so we have this as the y-intercept sept, and this as the slope of the regression line. So now what the task given here is that we have to predict the score when the student studies for 9.25 hours a day. So let us do that. Score when number of hours is equal to 9.25 is. So let us execute this function. So this is the output. So the score when the number of hours is 9.25 is basically 92.9. So let us see the content. So it is better to obtain this in the form of an integer. So what we can do is that simply put it as, so simply put this as int of, so 92. What previously we had was a floating point number. Now we have an integer. So the score when the number of hours is 9.25 is 92. So this is how we have prepared our regression model. Thank you.